Now we are going to discuss about rules for making ray diagrams. Many of you don't know about ray diagrams. Ray diagrams are the diagrams we are using in case of explaining the concept of light or optics in physics. We simply use rays in diagrams to show the formation of image, formation, reflection, and formation of different type of refraction. All those things we can explain by using such type of diagram, the diagrams where we use rays. So always remember, in case of ray diagrams we must use arrowhead so that we can easily point or indicate that which one is a incident ray, which one is a reflected ray, or ray goes on which direction. So let's start. Rules for making ray diagram for the formation of image in case of concave mirror or convex mirror. So first rule says that any ray of light traveling parallel to the principal axis after reflection either actually passes through or appear to pass from the principal focus of the spherical mirror. So suppose there is, it may be any type of mirror, it may be concave or maybe convex. I am using concave. How you justify that which one is concave, which one is convex? Suppose this is your palm, this is your mirror, clear? Just behind the mirror there is a polished part. You can easily say that this is a very smooth, very fairy one, and this one is dark one. So this is your polished part, this one is polished part, and this one is your simple reflected part from where light ray is reflected. Actually light ray reflect from polished part, and this is a plain part. Now this is your plane mirror because it's a very plain, and polished part is outside, it's a concave mirror. Polished part is inside, it's a convex mirror. Once again, if polished part is outside, it's a concave mirror, and polished part is inside, it's a convex mirror. Clear? So this is your concave mirror if polished part is outside. Clear? Now, if any light ray parallel to the principal axis coming from infinity either actually passes through the principal focus, suppose this is F, this is C, principal focus after reflection, or in case of convex mirror, after reflection it appear to come from this point F. So this is the first rule. In case of concave mirror, actually pass through the principal focus, and in case of convex mirror, it appear to pass from principal focus. This is your convex mirror, and this one is a concave mirror. Clear? This is your first rule. What about second rule? Second rule is just opposite. Let's start. Yes, second rule says that if a light ray coming from the principal focus, or passes from principal focus of any spherical mirror. Suppose this one is your concave mirror. Clear? This is your principal focus, and just double distance there is a center of curvature. Always remember. So if any light ray passes from principal of focus incident on mirror, and after reflection it becomes parallel to the principal axis. This is your second rule for making diagram. If any light ray passing from principal focus after reflection, it becomes parallel to the principal axis. Then in case of convex mirror, any light ray appear to come, because in this case focus is not real one, appear to come from the, suppose this light ray appear to come from principal focus. After reflection it becomes parallel to the principal axis. Clear? This is your second law. In case of concave mirror, actually pass. In case of convex mirror, it appeared to pass. Then after reflection it becomes parallel to the principal axis. This is the second rule. Now discuss the third rule. Second rule says that any light ray which passes from center of curvature of the spherical mirror, suppose this is your concave mirror, and any ray of light which passes from center of curvature, after reflection it retraces the path. If this moves and fall on the mirror, after reflection it again come back or retrace the path. This is the third rule of the ray diagram, that if that ray passes from center of curvature, it reflects back on the original path. This is in the case of concave mirror. In case of concave mirror, all things are real, but in case of convex mirror, this is your imaginary one. So here you have a center of curvature. So in case of convex mirror, if any ray of light appear to fall or pass to center of curvature, it reflects along its original or initial path. It is known as this is the third rule of convex mirror. Okay, so these are the three rules of your making a ray diagram. Sorry, I'm a little bit disturbed for some exterior reasons. Some persons are coming inside the room, that's why I'm disturbed. Please ignore that one. Hope all these three rules are clear. Once again, you must read the rules from your book also. Now we are going to discuss formation of images by using concave and convex mirror. Now our heading is formation of image by concave mirror. To avoid this spot, I fly my handwriting like an aeroplane. So let's start of formation of images by concave mirror. Always remember that in case of formation of images, we use at least two rules. We discussed just under the heading of rules for making ray diagrams. So there are several conditions, and we have to discuss how we draw the rules. So I draw the images. First one is when object is at infinity. Object is at infinity. Always remember, I am discussing about concave mirror. So this is your concave mirror. Before starting, first draw the concave mirror, then principal axis of the concave mirror, and by using your scale, take the measurement of this is your principal, this is your pole P. From this, make some distance of F and just double its a C. Use scale for plotting these 2 points. Clear? P to F and F to C is always equal. Then light ray coming from infinity parallel to principal axis incident on spherical mirror. Clear? Parallel to principal axis incident on incident on your spherical mirror or concave mirror, and as first rule says that after reflection they must passes through focus. Clear? They must pass through focus. So this is where these two rays meet. That point is a point for formation of image. So this is your first ray diagram, and after writing ray diagram you must write down at least 4 properties of the image. So what are the 4 properties of the image? First one, A part is your let me write this side. A part is your type of image quality. So they are actually meted, rays are actually meet. So always remember, if ray actually meet, that image is your real image. Clear? Image is real. After this, where they meet at focus. So image formed at focus. Image formed at focus. Then always remember that if there is any real image, the image must be inverted. Real image never be erect one, it always inverted. Now fourth is size of the image. In this case, image is highly diminished. Image is highly diminished, means very small. It is your highly diminished. Image is your highly diminished. Now this is your first part of the image. Now second point is object is in between infinity and center of curvature. Previously object is at infinity, now object comes closer, there is a focus, and just double, there is a center of curvature. Use your scale. This is your pole P, and the straight line is your principal axis. Now if object is in between center of curvature and infinity, suppose your object is at this part, this arrow is your object. Always remember, from one point of point source there must be 2 ray emit and fall incident on the mirror. So first condition, light ray parallel to the principal axis. After reflection it passes through the focus. This is your first rule. Clear? Now second rule says that we see that ray must passes through center of curvature. So line is a little bit curvy one. Center of curvature. Clear? I am using my free hand, so line may be curvy, but you people must use your scale. Clear? Fall on center of curvature, and after reflection they retrace their original path. Now previously image formed at focus and object is at infinity. If we bring closer to the object, image move away from the mirror. So image formed in between center of curvature and focus, image is real, image is a little bit smaller one, likewise. So what are the properties? Real, inverted, real inverted, then formed in between, in between C and is center of curvature and F, it means focus. Clear? Then D is your about size, diminished in size. It is little bit small, larger, but it also diminished. Diminished in size. Diminished in size. This is your second one. So let's start. New topic is object is at center of curvature. Center of curvature of your principal axis or your mirror. Students, I am using my free hand, so figure must not be appropriate, but all of you use your ruler or scale. So object, okay, little bit I am taking little bit larger distance. This is your F. Now I am using the measurement. This is your C. Clear? If object is at C, more closer, parallel to the principal axis, after reflection it passes through center of curvature. Then next one is, because though it's a center of curvature, so we are unable to use this point, so we use the second law that passes through center of curvature, for principal focus. After reflection it becomes parallel one, and they actually meet at center of curvature. So image is your real inverted, form at center of curvature, form at C, and size is equal size. In this case size is always equal. So hope this one is also clear. Now move to the next part. This is the third point. This is the third point. Next point is, so our next point is object is in between center of curvature and focus. So what happened? This is your center image, not image, it's a mirror. This is your concave mirror. This is your focus, this is your center of curvature, and object is in between somewhere at center of curvature and focus. Now what happened? A ray of light parallel to the principal axis after reflection passes through the focus. This is your ray of light, one. Second one, it must passes through it falls such that at the point that after reflection, that's why I am saying that you will use your scale. Clear? After reflection it retraces its path and meets somewhere just beyond the center of curvature or in between center of curvature and infinity. This is your image. Clear? Image is this time larger one. So quality of image, first one it's a real, second one inverted, third one enlarged, and fourth one about your position in between C and infinity. Clear? In between C and infinity means center of curvature. My figure is not perfect. I'm really disappointed with my figure, but though I'm using free hand, but you people must use your scale so that this line ray must be straight, and try to, in this condition, try to take this object just nearer to the focus so that you have a perfect second rule. You follow the perfectly second rule. In this figure, my mistake was that I choose the place of object just nearer to the center of curvature. We use either mid or nearest to the focus so that we have a perfect image. So let's move to the next topic. So our last point for the formation of images by concave mirror is if object is in between pole and principal focus. This is your pole, this is your mirror, this is your, somehow it's a focus, it's your center of curvature. Clear? So question says that how we follow. So see, there is a place, first after reflection it passes through principal focus, and second, let's use some scale. I have a little bit largest scale. Clear? It passes through center of curvature, and after reflection it passes, it fall on incident on light of rays such that it fall on center of curvature. So this type of condition, light ray not actually meet in concave mirror, but if we produce light ray backward, so it actually appear to meet somewhere at the back of the mirror. So image, in this case only we have a virtual image. Image is imaginary. First one, it's not real, it's a imaginary or virtual. It's a virtual image. Only at this condition we have virtual image. It's a erect, enlarged, and behind the mirror. Behind the mirror. So whenever question asks to you that draw the diagram of given condition, you must first draw the diagram, give proper arrowhead and labeling, all the things. Then you must write down all these 4 points. Then only your diagram is complete, your answer is complete. Doesn't matter whether your question is of 1 marks or 5 marks. You have to draw it completely. So these are the about concave mirror. Next we are going to move about convex mirror. In case of formation of image by convex mirror, we have only two conditions. First, object is at infinity. So let's discuss. Object is at infinity. Clear? So what happened? In case of convex mirror, object is at infinity. This is a pole. So convex mirror focus is just behind, just double the center of curvature. Clear? So if light ray falls, or beam of light ray falls on the spherical mirror, it reflects this direction, but if we produce, they appear to come. So imaginary rays we use by the dotted line. Clear? So they appear to meet at focus. This is your first condition. When object is at infinity, they appear to meet at focus. Image is first, it's a virtual image, as usual, virtual one, diminished one, very small. Though it's a virtual, so it's also erect and formed at focus. So these four are the qualities of the image when object is at infinity. Now next point is, so next topic and last topic of this video is object is in between pole and infinity, anywhere in between pole and infinity. This is your pole and that is your infinity. Just behind the mirror we have principal focus and we have center of curvature. Clear? Now let's start. If any place we have object parallel to the principal axis, after reflection it's a focus. Clear? Then second one, if light ray clear, so it retraces the path and appear to meet somewhere in between pole and focus. Pole and focus. Likewise, then first virtual image, then erect, okay, then C smaller in size, small in size, D between P and formed between P and F. Clear? Only these two conditions we have in case of convex mirror. So all of the you must practice for preparation of the figure. Read rest of the uses of concave and convex mirror from your book. That's all for today. Thank you.